Hello. So today we are going to learn what is linked list today. So uh, yeah, after this we are going to solve it for problem. So what is the linked list? A linked list is a data structure that stores data in nodes. Okay, it will store data in nodes. Okay, so each node has data. Data means value of the node. Like if you have some values like 20, 30, 40, like that. Okay. So next pointer address reference of the next node. So unlike array, list elements are not stored in a continuous memory location. Okay. And for example, head, like if you have, this is the head for linked list, and this is the 10, this is the value, and this is the next. This is the another another node 20, and this is the node next of 20, and this is the next again, and this is the 30 and next for next, and this is the none, and this will also called a tail. Okay, so linked list versus array list. Okay, so array in Python list, like array equals to you have 10, 20, 30. So contiguous indexing fast. I mean it has fast indexing. Like array 1 equals to 20. We can find out here array 0 equals to 10 and array 1 equals to 20. Linked list is scattered in memory. Okay. Head. This is the head of linked list, and this is the list 10 next, 20 next, and 30 next. Okay. Array is a fast indexing. Okay. Slow insert and delete operation in array. Linked list slow indexing, fast insert and delete. If node reference none. Okay. Use array if you need fast access. Use linked list if you need frequent insertion and deletion. Delete deletions. Okay. So type of linked list are single linked list. Okay. So if you have each node point to the next node only. So like if you have node like that, 10, 20, 30, and 1. So double linked list, each point, each node point to next node only. Each node point to the next node only. This is a single linked list, and double. Each node has two pointers, previous and next. Previous point, pointer and next pointer. Okay, so here you can see this is the none. It is called a head. This is the value, and this is the previous of this node, and this is the next of this node. Okay, so it has a next and previous two type of pointer. And some circular linked are last node point back to the head from a circle. Okay, so it will like a circle. Okay, like if you have 10, arrow 20, arrow 30, it back to the 10 again and circle. Okay, so you can see here uh, linked list data structure. Okay, so if you have like a head, this one, this is the address, and then next, and this is the next, and this is the address of this node. Okay, so here you can see this is the first node, second node, third node, and fourth node. This is the last one. This is also called a tail, and this is called a head. Okay, data linked list are non-contiguous, and memory allocation allocate only one by one to the element. Okay, that's why it is slow. Insertion, deletion efficient, and access sequentially. And linked list. Okay, an array data structure continuous. Memory allocation allocate to the whole array, and insertion, deletion insufficient, and access randomly. So here you can see single linked list. So here we can see single linked list, like we have had, and here you can see now this is the point 1, point 2, point 3, 3, 4, 5. So this is the single linked list fundamental data structure. Okay, it consists of node where each node contains a data field and reference to the next node to the linked list. The next of the last node is null, indicate the end of the list. Linked list support efficient insertion and deletion operation. Okay, so this is a single linked list. We can see the flow of linked list. Yes. Okay, now we can see we also do element analysis. Okay, no problem. This is another linked list and this is another linked list, single linked list. And our linked list we have two pointers, previous and next. Okay, so here we can see double linked list. We need to go back. Here we can see double linked list. Okay, so here a double linked list is a more complex data structure than a single linked list. What it offers several advantages. The main advantage of double linked list is that it allows for efficient traversal of the list in both the directions. This is because each node in the list contains a pointer to the previous node and each point to the next node. This allows for quick and easy insertion and deletion of the nodes from the list, as well as efficient traversal of the list in both directions. Okay, here you can see it has a previous and this one is previous and this is the next. It is 2 point. That's why it is called the double linked list. Okay, so this is our node 1, node 2, and node 3. Each node has a previous pointer and next pointer to store the data and value. Here you can see this is the previous point and this is the next to store the address of the next node and to store the address of the previous node. Okay, so here I can put these images here. Okay, now we move on circle linked list. Okay, here you can see circle linked list. Okay, so introduction to a circle linked list. A circle linked list is a data structure where the last node points back to the first node and forming a closing loop. Okay, last node point back to the first node and forming a closed loop. All nodes connected in a circular form, enabling continuous traverse without encountering null. It is different from regular linked list. In regular linked list, the last node point to the null, whereas in circular linked list, it point to the first node. Last node will be point to the first node. Idea for tasks like scheduling and managing the list, where smooth and repeated. Type of circular linked list. We can create circular linked list from the single linked list and double linked list. So circular linked list are basically of two types. Circular linked list, circular single linked list. Okay, so here you can see this is the single linked list, and last node should be point to the first point. Here you can see data next. This is the first pointer, second pointer, third pointer, and last point should be connected with the first pointer. Okay, here we can only move through the list in one direction. And this is the circular linked list. Single type circular linked list. Now we can see circular double linked list. Okay, circular double linked list. Each node has two pointers, previous and next. Similar to the double linked list, the previous pointer point to the previous node and the next pointer to the next node. Last node is storing the address of the first node, and the first node will also store the address of the last node. Here you can see previous, and this is the value data, and this is the next. Okay, this is the pointer 1, pointer 2, pointer 3. Okay, so here last node should be point to the first node, and first node should be point to the last node. Okay, so here you can see double linked list. Advantages efficient traverse nodal pointer is used for repetitive task insertion or exiting and it's O1. Uniform traversal efficient memory utilization. Complex implementation and finally these are the disadvantages. Harder to use device deletion complexity, memory overhead. Okay, not cache memory. So here need to move array in memory. Okay, so array element are stored continuous side by side in memory. Okay, so here you can see index 1 we have value 10 sorry index 0 we have value 10 and address 100. Okay, and index 1 we have value 20 and address equal to 104. And index 2 we have value 30 and address equal to 108. And 3 index 3 we have 40 value and address equal to 112. This is the accessing an element like a array tree is very fast. So address of array of I equals to base address plus I into size of the element. Okay. So array in the memory. Okay. And linked list in memory. So in linked list element are stored as a node. Each node has 2 points like previous and next. And data the actual value like a 10, 20, 30. I mean this is the data actual value. And pointer the memory address of the next node. Okay. Pointer means memory address of the next node. A node like it has a data and the next pointer. Okay. Example linked list like a head. This one head one data and next. Here you can see data equals to 2 and next and 4. Here is also next and here 5 and 9. Okay, head point to the first node. So first node is called a head, and each node point to the next node. Okay, here you can see one is connected to 2 is connected. So the last node point to the null. Null is called null or cell. You can also set cell. So important point, node are not sorted continuously. When you create a node, it gets memory from any space in them. Okay, like here you can see node 1 and data 1 equals to address 100, 200, node 2 data address 540, node 3 data equals to 4 address 120, and node 4 data 5 address equals to 999. So extra memory is needed for storing the pointers. Okay, in linked list, extra memory required. Bandwidth size, unlike array, we don't fix the size of the at the start. Access is slower, must traverse for head, node 1 and node 2. Difference from array. Array fast access, fixed size. Array fast access and fixed size, and linked list slow and dynamic size. Difference from linked list already I told you like this is the pointer 1, pointer 2, pointer 3, pointer 4. The data and this is the next. This is the head and this is the null. Okay, so here you can see this is the basic of linked list. I think we got it. Now we are going to perform operation of linked list. Okay. Bye bye.